Hello and welcome to another of Turtleton's tutorials. Today we're going to be looking at how to make a portcullis using fence posts and pistons in Minecraft. And we're going to start off by looking at some of the problems we have with sticky pistons. First of all, you'll see that we have here a sticky piston set up with 2 blocks. Now, sticky pistons have absolutely no problems pushing more than 1 block, but when it comes to retracting a piston, then the piston doesn't pull back both blocks, only one. And no matter how many times this piston is turned on and off, it will only retract the one block which is adjacent to the paddle. Now another problem we have with sticky pistons is when we're trying to push 2 pistons at once. So one piston at the bottom is trying to push one piston at the top. You'll see here, if we turn this on, again, both pistons have absolutely no problems going up. You see power is being applied to both pistons. But when we turn the pistons off, you'll see that because they're trying to retract at the same time, the lower sticky piston is unable to retract the top piston because it counts as being fully extended. And one sticky piston cannot retract a fully extended piston. So we get in this problem where we have to be quite clever about our means of retracting pistons. And this is going to be useful because with a portcullis you need to push the gate up and you need to pull the gate down. And without 2 sets of pistons you're going to be unable to do it. So here's a method we have of actually controlling 2 pistons in a fashion where they'll function. I'll just show you how this works and see if we can get a convenient angle on the switch. You'll see that both pistons will go up and both pistons will come down. And here we have the means of doing that. You'll see that power or redstone dust doesn't actually travel to the top block. And you'll see that we're actually powering the piston effectively by powering the adjacent block. One issue with redstone dust is that it's always trying to power all the adjacent blocks and trying to bleed through them. So you can see in this case the redstone dust is here, and this will actually try and power up everything surrounding it in both dimensions. Again, with this piston, or this block, it will power all around here. Powering up these blocks, propagated power will pass through simply to the block on the side that the power is on. So we can do this. Furthermore, you'll note that we have a slight delay of 2 ticks here, which means that this piston is always going to be the last piston to react, giving this piston enough time to withdraw its paddle before it's actually pulled back. Now, this isn't the most attractive or convenient way of powering this up. As you'll see, we're running it on both sides of the pistons, and we have a large stretch of piston, or a large stretch of redstone dust running all the way around. So, in this method, we're following it from all one side. And you can still see it still functions. Here you go. So effectively we're using redstone propagation again, getting picked up by this repeater. And again you'll see here that we're powering the lower piston via the block at the bottom, again propagating through this white wool. And this is simply to discourage all the redstone power to bleed through onto surrounding areas and causing us lots of problems later on. You'll also notice at the top I've added another redstone repeater. And this is to, if I can show you this properly, this is simply to allow for multiple rows of pistons to be set up, because obviously we're going to need more than one set of gravel to push our gates upwards. And you may be wondering why I'm using gravel, and it will become much more apparent later. But you'll see that we can use the gravel to actually push up our fence posts if they were placed on top here, giving us a 2-gap hole And then, because gravel is affected by gravity, when we pull the pistons back down, it will reset to floor height. Now, of course, we're going to have the same thing pushing down. This is a pretty similar method, just it looks a little bit strange. I'll just show you it working first. Here you can see, note that this bottom piston is a regular piston, it's not a sticky piston. As you can see, we have our redstone repeater giving us a delay, and it's powering the top piston. And the lower piston, again, is being powered one block diagonally away from where it started, thus where it's going to be when it's pushed by the other piston. There we go, that pushes down and is reliable. So, the design put together gives us this rather monstrous thing here. Now, I'll show you it working first so you get some general idea of what we're trying to do. Pressing this button here pushes the portcullis, made up of some fences here, and seems to have actually misfired. There we go. That gives us our gate big enough for us to pass through. And pushing this lower button causes this to happen. I'll just show you that a few more times. Now, the lower gate is controlled essentially as we've had it before. You can see here now we have 3 stretches of redstone repeaters powering the lower block for the lower set of sticky pistons. And if we just travel up here, you can see again that we're powering this set of pistons here. We've added our redstone repeaters so we can daisy chain them up. And there's nothing too complicated about it. For the upper set of block, you'll see we've got a rather ugly string of staircasing for the redstone dust. And this redstone repeater here is merely to make sure power reaches this distance. And we're powering, in this case, the lower pistons first, again diagonally 1 block down. Slightly further up, we're then running the wire across this top set here. Now this is slightly different from our designs way down there, but in much the same principle, running redstone power along this one will power these blocks which propagate through to the pistons below. Again, if we hit the right side, you can see this working. And of course you can actually make the gates, or the fences, much longer, but of course you'll have to incorporate that in your design because there always must be 2 blocks worth of gap to allow you to pass through it. And we can make it much wider, as wide as you like and as high as you like, provided you have no limitations otherwise. So as Knight is drawing, I'll show you our final version. We have here a means of opening the gate and closing the gate. When the gate is closed, you'll see we are unable to pass through. You can see the pistons above, which can be replaced by a sticky piston and a further block to hide them. And to be fair, it looks somewhat quite similar to a regular portcullis. Of course, the design of the gate itself can be altered to however you see fit. And when the sand is come up, it gets reset to this level. Conveniently, I have a sand floor to hide it furthermore, but it's not too much of a big deal if you don't. And here's our workings from the inside. Now, as you can see, on this side we have virtually, or literally no redstone wiring visible. On this side, I've shown you how to more conveniently run the wire up the inside of the wall. Now, all this can be covered. This can be filled back in with your flooring, and you maybe only lose 1 internal block's worth of redstone wiring. So, this merely is coming from our switch, becomes inverted, and gets placed and passed up here to power our circuit. Again, much similar to our large design over there, and by powering through the top. So, there you have it. a working portcullis. It's fairly reliable, it's fairly practical, and above all, it looks pretty good. And of course, if you want to refer back to my tutorial on switches, you'll be able to see how to replace these two buttons with just one button, and you can have one on either side of the gate. It's not much of a stretch to do, and it should give you some good practice and make the whole thing a lot more practical. This has been Turtleton's Tutorials. Thank you for watching, and I hope to see you again next time.